Now in this one, we're going to do the same thing we did in the last one, but I think because of the exponential in here, the calculus is going to be a little trickier for us. So let's start with finding the critical points. Okay, to do that we need fx, which would be, all right, let's think, xy times the derivative of e to the negative x minus y times the derivative of the interior, right? So it's product rule. So xy times e to the negative x minus y times the derivative of the interior, which is negative 1. And then we're going to add to it. And this time, we're just going to take the derivative of xy, which is y, and then e to the negative x minus y is left alone. Whew. All right, so product rule is what we're doing, right? We have one function xy times another function e to the negative x minus y. So we're using product rule. Right? Take the derivative of the second part, leave the first part alone, and then reverse it. Okay, so if I'm going to look at this a little bit, I'm going to factor out both these terms have a y and an e to the negative x, excuse me, e to the negative x minus y. So if I take that out, left in here is a negative x plus a 1. So 1 minus x, if you will. So that's a little simpler. All right, we're going to set that equal to 0, and we'll figure that out in a moment. Well, actually, I take it back. I guess we can do it right now. If this is going to be equal to 0, either right, because exponentials can never be 0, we're never going to get a 0 out of this part. So that's off the market. So either y is 0 or 1 minus x is 0, which would mean x is 1. All right, so there's our two options. We're going to keep those in mind for later. Right? Okay, so now what about fy? Fy would be the same thing. It'd be xy e to the negative x minus y times negative 1 plus x e to the negative x minus y. Right? It's very, very similar, but almost identical. And we would set that equal to 0, but I'm actually not going to set it equal to 0 right this second. Give me one moment, because I'm going to do what I did on the last one and simplify this a little bit. So I'm going to take x e to the negative x minus y out, and that'll leave me a 1 minus y left in there. All right, so there's my fx and there's my fy. Now if we want to substitute, right, we know that it kind of has to happen at certain values, but we should also be able to think about this in terms of both these things have to happen simultaneously. They both have to be equal to 0 at the same time. So let's think about this. If y was 0, if I took the y equals 0 value and I put it in here, that would turn this into 1. So the only way we're going to have it equal to 0 is if x is 0 at the same time, right? Because 0 times this thing times 1 would be 0. So either x is 0 when y is 0. Sorry, that's my x. I wrote it badly. Right? So if you put 0 in for y and solve it for x. Actually, maybe that's the way I should write it. One second. There. When y is equal to 0, I plug 0 in. The only way this whole thing is going to be equal to 0 means that x must have been 0 at the same time. Okay. What about when y equals 1? Oh, no, sorry. When x equals 1. That was the other value we had. Sorry. When x equals 1. Okay, so if I put in x equals 1, I'd have 1 times e to the negative x minus y times 1 minus y equals 0. And the only way that's going to equal 0 means that 1 minus y has to be 0, which means y is equal to 1. So I'm getting the points x equals 0, y equals 0. So 0, 0, technically something. And then the other one will be when x is 1, y is 1, and technically there's some other value. 0, 0 is easy to figure out, by the way. If you go put 0 and 0 in for x and y, you're going to get 0. So that's pretty easy. 1, 1 would be 1 times e to the negative 1 minus 1. right? Negative 1 minus 1 is negative 2. So this is e to the negative 2. You don't have to do those right now. You can do them later. It doesn't really affect anything. Okay, so let's make the table. So we have our critical points, which are 0, 0, 0, and 1, 1, e to the negative 2. And again, you don't need to put the z components in right now if you don't want to. You'll do them eventually anyway. All right, so there's d. What's our fxx? And then what's our conclusion? So if you don't put the z's in now, you do it in the conclusion. So either way. All right, d is going to be a bit tricky to find. We got to take some time to do that because we're going to have to find the derivative of the derivatives we already found with respect to x and y. Oh boy. Okay, so that's going to be a pretty complicated product rule if we think of it here. And if we go back to the original, it's still pretty complicated product rule, but it'd be, let's think, y times e to the negative x minus y, right, times negative 1, plus, and then the complement of that, or not the complement, but the other side of it. All right, if we do it here, we can think of, okay, the derivative of this with respect to this whole thing, this piece, with respect to x would be, well, let's take the derivative of the first part, this part, right? Oop, yeah, sorry, this part, there it is. Take the derivative of this part with respect to x. Well, the only x in there is this negative x that's in the exponent. So it'll be, let me write it down here, fxx is y times e to the negative x minus y times negative 1 times 1 minus x, because the 1 minus x we didn't mess with, plus, right, now reverse it. The derivative of this would be left alone, and the derivative of this would be negative 1. So plus negative 1 times y e to the negative x minus y. Okay, well, these both have a y e to the negative x minus y, so I'm going to factor that out. I'm going to have a minus 1 times a 1, which is minus 1, and a minus 1 times an x, which is x. So I'm going to have an x minus 1 minus another 1, so minus 2. Right? In other words, I'm factoring this out. So if you will, this is x take away 1, and then take away another 1. So combining like terms, that makes x minus 2. All right, so there's my fxx. fyy would be, okay, so here it is. The derivative of this with respect to y. So I would leave this part alone, right? The only y right here is the negative y. So I'd leave the first part alone. I'd write x e to the negative x minus y times negative 1. Times the 1 minus y, because we just leave it alone, plus, and now we're going to write the negative 1 because that's the derivative of this with respect to y, and then leave the x e to the negative x minus y. And just like the last one, they have some things in common. They both have an x e to the negative x minus y. So I'm going to take that out. That leaves me, if you look here, we have a y take away 1, and then take away another one right here. So it'll be y minus 2. All right, so there's fyy. fxy would be, let's see, this is going to be weird. So the derivative of this with respect to y is going to require product rule because we have a y times this. All right, so that would be, let's see here, y, and then the derivative of the interior part is e to the negative x minus y times negative 1, and then we just have a 1 minus x just sitting there, right? So it's like a constant as far as y is concerned. Plus, and then we have the derivative of y is 1, and then leave the e to the negative x minus y times 1 minus x there. Okay, so both these terms have a 1 minus x in them. So I'd bring a 1 minus x out, I'd bring an e to the negative x minus y out, and if you look, we have these two pieces left. a negative y, and a 1. So that would be 1 minus y right here. Oh boy. Okay, so what is d? D is fxx times fyy, which is x times y e to the, here let me write it, xy e to the negative 2x minus 2y, because if you multiply these you would add the powers, times an x minus 2 times a y, or excuse me, yeah, times an x minus 2 times a y minus 2, plus this guy squared. Oh, I mean minus. It's minus fxy squared. Sorry. So minus fxy squared, which would be minus this guy squared. So minus 1 minus x squared, 1 minus y squared, e to the negative 2x minus 2y. See, I knew the derivatives would be more complicated, right? It involves product rules and chain rules all over the place. All right, so we have to be extra careful, but of course we can use maple to double check ourselves. Okay, so here I named my function. There's the first derivatives right there, right with respect to x and y. Here's the fxx, just like we said. Here's the fyy. Here's the fxy, and then therefore here is d, just like I'm saying that it is, even though it's pretty ugly to look at. I could put in a simplified command, but it's not really strictly necessary. Okay, so now we have to look at this and we have to think what would happen if we put in our 0, zeros for x's and y's. So let's look at D. If I put 0 in for x and 0 in for y, this whole thing becomes 0 minus 1 times some positive number, because e to the 0 is 1. Right? So if you weren't catching that, it's going to be 0 take away positive, 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 right? And 0 take away positive numbers is negative. So this is a negative number at 0, 0, which means, I can write it right now, we have a saddle point at 0, 0, 0. All right, now what about 1, 1 e to the negative 2? Okay, well, if I put in 1 here and 1 here, right, for every x and every y. So this is 1 and 1. Remember, e to the something can never be negative. That's going to be a positive number no matter what. And then I multiply by a negative value and a negative 1. Negative 1 times a negative 1 is positive 1. So this whole front thing is positive. Positive, take away. If I put 1 in, it's 0, and we're done, right? 0, 0 times a positive number. So 1 take away 0 is positive. And of course, you could just go substitute, right? I have this function named in Maple, and we could tell it to evaluate it at 1, 1 if we wanted to. All right, now fxx. Because this was positive, we have to check fxx. So if I put 1 in for y, that'd be a positive times a negative number, right? Because 1 take away 2 is negative. So that means it's negative. And a positive followed by a negative is a maximum at 1, 1, e to the negative 2, because e to the negative 2 is actually a positive number. So this is bigger than 0. All right, let's look at the graph, which of course I drew for you. It's right here. Right, so we're looking at it right there, and it doesn't look like much, but there's a little tilt in there. Can you see it? There's a little gap. So one of those numbers actually is a saddle point, and the other one is actually a little local maximum. It's on the top of a little hill, right where it is. Fascinating, huh? I think you can see it better looking down the barrel of the y-axis a little bit here. So that you can see at y equals 1, x equals 1, that's this one over here on the right. It's up at the top of a little bit of a rise there, right? Whereas the 0, 0 is the saddle point. It's where it stops being one direction and starts being another direction right there. So the graph is in fact backing up our answers, though they were tricky to find.